Hello there. I would really like to thank the guys before. It will make my presentation really silly because they went really in detail. Hello everyone, my name is Amir. I'm going to do the presentation about our assignment at the University of Burton Network Switching. So we'll talk about firstly what's our customer profile, what are the requirements that this university needs from us as network designers was to deliver at the end. We'll talk about eventually the hierarchical network design, then our design for the university, some references and question time at the end. What is the customer profile? It's a university. It's a new one, so there's no infrastructure. It's a really simple, what they have at the moment is a simple infrastructure for computing. It's a small size, so it's not that huge. And the number of students, nearly 8,000, but they will not be all there at the same time. And we have probably 420 members of staff and admin and academic staff also. Two sites, we have on the university two sites within 20 miles of each other. So, and the distance between the buildings is approximately 3/4 of a kilometer, so that needs to be considered. Like I said, at the moment, only the staff, number of the staff, and the Faculty of Computing which have access to IT services. So, like I said, it's a new university, no infrastructure over there, so we can play with whatever we want because there's nothing there at the first place. Absolutely, the LAN design is to be flexible, high-speed connectivity through all the branches of the university. We need to deliver a high standards of the connectivity and of all the information provided to the university's network. And at the end, this is you need to keep in mind that this network design that you're presenting needs to be efficient for the next 7 to 10 years. What are the system requirements? Like I said, the guys over there went really in detail, so mine will not be that good. From the operational requirements, I figured this table in each building, what numbers of students we have, what number of admin, what number of staff, the number of printer and laser printers. The number of printers is number of users divided by 5 because it suggests that 5 people can share a printer. Then we will have at the end the total ports. So at the end of the day, at my design at the end, where the access layer needs to consist of nearly 1,200 ports. So that's a huge number. Okay, we're going through the list of the system requirements. We need to secure or to make sure that we have internal file storage, email, all the basics that we need to have to keep the network running. Absolutely, we need to provide segregation. Absolutely, it will be by segregating the staff, the admin, and the students by VLANs. It's the best way to do it. And because of that, my design was depending on layer 3 switches because absolutely at the end of the day, I want some kind of routing between the VLANs. So I need layer 3 switches because you can't just put a router over there. Internet access needs to be provided to all users. Video conferencing is very interesting. But the point is, I think that the guys before didn't mention that the video conferencing is not just between the two buildings. Because the university is looking for providing overseas education or distance education. So the video conferencing most of the time will be in those buildings, but sharing those videos or those meetings with the outside of the network. So it's not just the connection between the both sides for video conferencing. It's always as well having those videos conferencing sent to the internet or sent to some kind of a server, so you will have overseas students having some lectures. Absolutely, and provide the equipment for distance learning. Our budget is £1 million. I know it's for me as a person, that would be lovely to have £1 million lying there. But this is the budget that we will have, and like the guys before said, it will have some limitations because we're not speaking as on a small network. It's not a company. It's not one building. It's not 2 floors. It's 6 buildings on one side and 2 buildings on the other. It's a big network. So £1 million, if you want to scale it, it's okay, but it's not that much to play with everything you want. The dream, I read one of the papers, is a dream. If you want to give a network engineer a dream, give him unlimited budget in a building with all Cisco equipment and let him play. So he will design a network that is Superman network, I may say, supernatural. So that's the point. You will always have the cost limitations when you tend to design systems, because we are not in an identical world. So you need to have some kind of cost-effective plan when you design. The hierarchical network design, absolutely, from Cisco, will have 3 layers: core, distribution, and access. The specification of each equipment in each layer will disagrade until you get to the end point, which is computers, laptops, or IP phones. You will have a really complicated equipment in the core layer, and then lower in the distribution than in the access. The core layer, what is the core layer? It's the heart of the network, we may say. But because the good thing about this hierarchy is you don't depend 100% on your core, because there's some kind of network trafficking you can do just by the distribution layer. You don't have to go up to the core layer every time you want to switch traffic or route traffic. So we keep the core for the really heavy dealing with the traffic. So the main thinking, the main aim when we think about the core, keep it simple, because this is the hard stuff. We are managing all the network in this layer, so it needs to be simple. So provide high switch traffic, OSI layers 1 and 2. Provide the reliability, redundancy, and fault tolerance. That's absolutely true. You can't have a core depending on one equipment. You can have, like the guy suggested, 2 devices physically, but dealt with one logically. But you can't have physically just one device, and the whole network will depend on that device, because you will have a single point of failure. So you need to be redundant and fault tolerance for sure. You need to bear in mind that growing, you need to bear in mind faster technology that is coming in. Absolutely, this is the point that I mentioned before, that you need to keep it simple in the core. So you can't put an access control list in the core. That will destroy your network. Everything on that layer needs to be near the access or distribution. So you can't configure something like access list or traffic filters in the core. It needs to be really simple, just grabbing data or traffic from one place to send it to another. That's the main job of the core, and keep everything connected for sure. The distribution layer, this is the layer, or this is the place where it comes to dealing with kind of traffic, different kind of traffic, different type of media, different type, like I said, you can start with applying access lists and filtering at this level. Like I said, the routing needs to be away from the core, but it's done in the distribution layer. Absolutely, you need to create some boundaries here for the route aggregation and summarization, and at the end you need to manage your domains from this point, from this layer. At the end, the simple layer is the access layer, which is connect each broadcast domain together. So each probably laboratory or each floor, I may say, will have an access switch which can get connected several endpoints together, so they can talk within the same broadcast domain. The physical design. Here's the university. We have two main sites. I suggested for the WAN connectivity because I'm doing a lot of research on something called MPLS. I don't know if anyone here have some kind of information on. MPLS stands for multi-protocol label switching. It's a really nice or good new technology to deal with traffic rather than deal with it in layer 3. It deals it when in some kind of layer 2 to reduce the processing time. It depends on something called label, so it can boost up your network if you're talking about a WAN connectivity. The distance between the two buildings is 20 miles. This is the offer that I'm focusing on. It's from Virgin Media. We'll have up to 1 gigabit WAN connectivity between the two sites, and it depends on virtual private network MPLS. It's an MPLS-based VPN. MPLS-based VPN was my project when I'm doing my bachelor's degree, so that's why I prefer doing it this way. We're still in the physical design. We have, the point is we have these two sites and sub-sites we have here, building A and B and C and D and E and E and F. You have a WAN connection between two sites and you have absolutely a connection to the internet. So I'm planning on producing a WAN connection between the two sites and a backup plan. The guys before said this before me. I will have also an MPLS VPN backup for the two sites through the internet, because you can set up an MPLS VPN through the regular internet by contacting some kind of service with the provider, or you can have a dedicated LES line between your two sites to connect through any technology that you want. This is the LoRa's Joker is designed like the guys before assumed that the data center or my operational place will be in building A. So we will have two core switches, and the distribution there will be scattered between all the buildings. I will have, I'm not that scared. The guys before put two switches in each building. I will not go with that way because I think that would be really high in cost. I will keep just one. Try to think about some kind of redundant path for the switches, but I would stick to one switch in each building. For the, I didn't go into a lot of detail. This is most of them is a general design. But I'm thinking between two series from Cisco, which is Nexus and Catalyst. So we'll have Nexus 7000 in this place, 5000 in this place, and 2000 or 300 in this place, or Catalyst. They are two different types of routers and switches from Cisco. I want to see which is best for the university. I didn't decide yet, but mainly it will be rather either Cisco Catalyst or Cisco Nexus. So we will have then the core layer is connected to the server farm. Absolutely, all this layer will be connected through fiber. Then it's connected here to the internet. We will have the endpoints here. We have the printer, the laser printer, the video conferencing in some places. And the other thing, not all the desks in the university need to have IP phone. Just multiple of them. Then absolutely we'll have the wireless network. That's for sure for sharing the internet. Then we will have a connection through the core into the router to go to the secondary site. From in the secondary site, we'll have the router receiving the WAN connection from the main site. We will have a distribution router in each building. If you can see here in H and G, absolutely have the same infrastructure at the end. For sure, it will be less complicated because, like I said, in building A and B, you will have more students and more computing demanding students rather than in other buildings. So I just copied the idea that we'll have one of them or all of them or some of them. Like I said, the thing that I really thought would be good to have a backup route for the WAN, which will be on the internet. So I will need to have a firewall before getting into the network here, and we will have some kind of control server before getting into the network. So I will have some kind of a backup route from the internet. Absolutely, I will suggest MPS over there too. In the server farm that I mentioned earlier, we have some kind of security servers, a wireless LAN controller for the wireless. We'll have multiple servers such as domain controller, DHCP, DNS, email backup. You will have a remote access service, because in the operational requirements you need to make sure that some kind of staff or admin needs to have the right to access the network from outside. So we have a remote access server. Then absolutely the thing is, because we are depending a lot of on distant learning, you need to have some kind of a server to provide the information to those students overseas. So you'll have some kind of content management system here to manage the content you need to let those students overseas to use. We have a web server, that's for sure, in the DMZ. You have 2 firewalls to segregate them, then you'll go back to the internet. This is the references I used to gather all this information. Thank you very much for your time. Thank you very much.
Yes, very good presentation.
Okay.
So, any questions?
Hit me.
No? Okay, yeah, I think that's also very good practice. I think definitely your design consider different aspects.
Yeah.
But also, when you design your system, not only think about the network infrastructures, but also think how to provide network service. I think it's very good.
But like the most thing I thought of, I don't want to go to really deep in details,
yes,
because
yes.
I need to keep my options open for the assignment.
Yes.
It's
and
a general
also,
design.
Because now it's still only week 6, and
Yeah.
we have finalized the details,
Exactly.
configuration, and the price.
Yeah,
some,
the price.
some costly estimation.
Exactly.
So into your report. I think it's quite good.
Thank you very much.
Thank you very much.
Thank you.